So it's kind of one of these interesting moments in my career. If you had asked me in November of last year, like November 1st, you'd said, this is this thing, ChatGPT, that's going to happen in a month. And let me tell you what it's going to do, and you described it to me, I would have said, that's science fiction. That will not happen in my lifetime. And I'm a professor in computer science, right? I should see this thing coming. And I didn't see this thing coming at all. But once it showed up, like instantly, it was something just, well, pure magic is one way that I describe it, of what it could do. But since then, Doug and I have been sort of running around wondering, like, what is going on with the rest of the planet that they don't understand how transformative what has happened is, and understanding how this is going to impact everything we do. So a lot of what I'm going to be showing is really trying to give you a perspective on how powerful and capable and really exciting these new features and capabilities are in this technology, and then try to show you a bunch of real-world examples of it solving problems in business. And I'm going to use problems in Vanderbilt that hopefully will resonate with you. Now, normally I start off all these talks with like this example with Pokemon and crazy meal planning, and some of you may have taken my course. I'm not going to do that today. I'm just going to jump directly into talking about generative AI. So the thing you may have heard a lot about recently is prompts. So you can think of generative AI kind of like text messaging. So you go in and you type in a message, and your text messaging app, you send it off to a friend, and they text you back an answer. Or you type in a text message to them, you send it off, and they text you back a photo or a selfie that they took in response. And you could, if you had the right friend, you could write, you could send them the message, write a poem about the French Revolution, and they might text you back a poem about the French Revolution. Or you could say, create a Pokemon game for my child, and they might text you back. And generative AI is like the friend that no matter what you send them, they will text you something back. Doesn't matter what it is. It doesn't mean that it's going to be fact, but they can always respond, and a lot of times it has deep, deep reasoning and computing and knowledge in the response. It's not always right, and that's actually okay. That's actually a feature, not a bug, in my perspective. But basically, generative AI is you type in a message and you send it off to the AI, and the message that you type into the AI is called the prompt. And then the response that it sends back, the message it sends back, is just the output or the response, however you want to think about it. And these are all examples of prompts. They're not particularly exciting or interesting ones from a business perspective. Now, the thing that is really interesting is prompts are going to become the new interface to computing. So we think of the graphical user interface, buttons and pressing, as being our interface to computing. We think of programmers as being the interface to computing, but this is the new interface to computing, is prompts. And I'm going to show you what it looks like when you use generative AI as the basis of your computing, and prompts is how you interact with that computing. So I'm going to start with one of my favorite documents at Vanderbilt. It's the Travel and Business Expense Policy. So it's 20-page PDF. And I joke whenever I show this example, I've never read this document. I've submitted many expenses that have been rejected because of this document. And then I read the comments, and kind of like AI, I respond to the prompt from the person who reviewed it, and I update my answer to get it approved. But this is a great example of a common business case. How do we deal with like policy documents, other things that nobody wants to read? Well, it turns out I've actually read this, but not directly. I've read it through ChatGPT, using a tool that they have called advanced data analysis. It used to be called Code Interpreter, and then they changed it to advanced data analysis, and now they give it two names as of their launch yesterday. I created a course on it as Code Interpreter, I renamed it to advanced data analysis, and now I don't know what I'm going to do with the name. But I'm going to upload this document, and I'm just going to say, please read the provided document so you can answer questions about it. And it goes and reads it, and now I'm going to, and basically I also did a bunch of prompt engineering, basically knowing how to interact with it in prompts and get it ready to answer the questions the right way. Now I'm going to ask it a question that looks like the questions I actually ask, which is, let's assume I'm in a foreign country traveling in a taxi and it breaks down on the way to an important meeting. Can I get reimbursed if I pay someone to drive me on the back of their motorcycle to the meeting, assume they are a private citizen? And so what does ChatGPT say? It says, based on the information provided in the document. Now, this is the first thing, as you see over and over the news about, they don't know your data after 2021. They're still making a big deal of April, OpenAI was saying we trained up to April 2023 now, but it really doesn't matter because it's all about you give it the information you want it to reason about. So it says, based on the information provided in the document, university requires travelers to select the most reasonable and economical form of transportation. That is true. Non-conventional transportation options are not explicitly mentioned in the policy. That's 100% true. And Vanderbilt does not have a separate policy on ride sharing. And that is a direct quote from that document. Given these points, it seems plausible that in an emergency situation where no other reasonable and economical form of transportation is available, the cost of transportation by a private citizen's motorcycle might be considered an allowable expense. However, the university's policy does not explicitly state this, and reimbursement may be subject to review. That's like an excellent answer. And I read it in front of the Vanderbilt business managers. Nobody said anything. They're like, yeah, this is fact check and accurate. We might allow it and we will review it for sure. So it absolutely can do a good job of thinking about it. But we've seen lots of examples of things like this where we have it ask questions and we answer questions about a document. But the depth of reason, well, let me just back up for a second. Basically nothing that we had before November could do that at that quality. Like just like flat out. And if you could do something like that at quality, it wasn't as easy as upload the document, do some prompts to get it queued up, and then ask the question. Way more difficult than that. Very few people had access to that type of thing. But let's take it a next step further and start really thinking about how this is going to change computing, and particularly in business. So it's one thing to be able to answer questions about the policy and cite the right parts of the document, but it's a completely another thing to be able to understand the policy well enough to apply it. And so I'm going to upload a rental car receipt into advanced data analysis. So this is just following up in the conversation. So I'm basically creating a new prompt, and my prompt is the rental car receipt plus please analyze the attached and let me know if it complies. And it says, collision damage waiver. For domestic travel, the CDW should be declined as rental vehicles are fully insured through the Vanderbilt insurance portfolio. The receipt shows a charge for CDW, which may not comply if this is domestic travel. So if I had to program that, that would take me probably years with a team, and we probably wouldn't be able to do it that well. And how did I get here? With a couple of prompts, I give it the right documents, the right instructions on what to do, and you still have to know how to solve problems with prompts. But I'm building an entire application, essentially, now that can review a receipt simply by having the right prompts, the right prompt engineering, the right information, and now I can go and review a document. Let's look at another example. So this is the Vanderbilt Instructional and Enrollment Report. It's like a 17-page PDF that the registrar puts out. And if I wanted to do something with this data before these tools came out, I would have gone and I would have taken this document and I probably would have cut and pasted out of all these tables. Because like extracting that information in any automated way is really painful and difficult. So I would have gone and cut and pasted out all these into like Excel or somewhere else, and then I would have generated a bunch of visualizations, done stuff with it. Now let's look at what we can do with this, with these new tools like ChatGPT Advanced Data Analysis. So I'm going to upload the PDF. Now notice I'm not giving it an Excel file, I'm not giving it CSV, I'm not giving it a feed of data, I'm giving it something that was built for humans to read, a PDF. And I'm going to start off real simple. I'm just going to tell it, please extract each page of this PDF as a plain text in a separate file. And it goes and does it. It splits the PDF apart and gives me links to where I could download all the pages. And let me just say, as a computer science, this is like crazy, right? I just told it a program, essentially. I want you to take this, do that, and it did it. Now, we had tools that could do that, so that's not that exciting. But where it starts getting really interesting is when I say, now, turn this into Excel. And it takes that PDF page and it turns it into an Excel document that I can now download, open in Excel, do whatever analyses or visualization I want. And there was nothing that would work like that for arbitrary PDFs and things. Now you could go and hand massage this. You could have a team of programmers who built all these custom pipelines and data cleansing to try to get to this point before at enormous time and cost. But all I've done is taken the document, split it up into some files, done a little more prompt engineering, and then said turn it into Excel. And now I've got Excel. But the interesting thing is, why would I actually go to Excel when I already have the data in the tool? And I can do something like this. which is just follow up in the conversation and say, display 4 interesting visualizations of this data. And it comes back and it generates 4 visualizations of the data. Now I want to point out something. I want you to look at my prompt here. Notice what I didn't tell it. I didn't tell it what to visualize. I didn't tell it how. I didn't tell it the type of chart. I didn't tell it what axes or anything. I just said display. Now I could have done all those things, but this is the exact opposite of the way that we've done computing for decades. It's a whole new way of doing computing where the adjectives can matter. And people are discovering right now, and we're actively discovering, Doug and I are, and Dana and others, about like what matters and how you say it and what the wording, what is the impact. I can tell you one concrete example. So in code, like if you're having it generate source code, it matters. So if you say generate code that's fast, it matters. If you say generate code that follows these design principles, you will get more likely to get code that follows those design principles than if you don't. And so you can think of it as like, it's really your, like if you had a software engineering team and you're trying to get them to build something, you're going to give them requirements about what you want. And this is essentially your requirements. And so the more detailed your requirements are, the more likely it is to generate what you want. And so knowing how to ask and what to ask for really matters, 100%. And I'll come to that in 1 second. So that's a great question. So it generates these visualizations. And that is pretty wild and transformative. And then I thought about, like, when I'm doing this, if I'm creating these visualizations, I'm probably not doing it just for the fun of it. I'm probably doing it because I'm going to give a presentation like this. So wouldn't it be cool if it could help me automate the bane of my existence, which is generating PowerPoint slides? So I upload my slide template. And this is just my PowerPoint slide template. It's the same one I use for this. And I basically tell it, save each of these visualizations as an image, then insert each of these images as separate slides into the attached PowerPoint. And I give it some information about how I want them laid out. And then I tell it to put a text box next to it that describes what's in the visualization. And it generates the PowerPoint, and I download it. And this is the PowerPoint opened up in PowerPoint. And we can see each of the visualizations is now a separate slide. And it's got a nice little description of what it is. The heat map visualizes the correlation between different enrollment categories. It helps in understanding the relationships between full-time, part-time, men, women, and total students. So it generated a visualization. It generates the explanation of it. It turns it into PowerPoint, all these things. And that's really exciting. But people should be freaking out about this. And for a very specific reason that, as a computer scientist, gets me excited. And that is, what just happened is kind of like if you went into your backyard and you were going to dig a hole with a shovel, and right before you go to dig, your shovel looks down and sees that there's a rock in the way, and your shovel jumps out of your hand, builds itself a pickaxe, breaks up the rock, and then jumps in your hands, and you continue digging. And that is your tool foresaw a problem in front of you. It built itself a tool. It used that tool to solve your problem, and then it got back in your hands, and that's what that just happened. So when I asked it to create that PowerPoint presentation or those visualizations, as you're working with it, these little gray boxes are popping up, and that's the tool building tools for itself. And the tool it built is software. So when you click on that box, it expands, and it wrote itself its own program. And it was a custom program dynamically generated to help you accomplish your goal. And so when I said, create a PowerPoint or create a visualization and then save those images and then put it into the PowerPoint, it wrote a Python program that would do what I asked it to do. It executed that Python program in the cloud autonomously, got the PowerPoint presentation back, sent it back over, and gave me a link so I could download it. So it built itself a tool. Now, people were freaking out when they discovered, right, that gorillas were taking like blades of grass and sticking them into the termite mounds to get like, animals are using tools. I'm a computer scientist. I'm like, my software just wrote its own software. What on earth is going on? So this is like wildly transformative. Now, it's clearly going to change what we do in computing. Now, it's going to change it in all kinds of ways. We're going to see things like this. We're going to see more of the, just prompt engineering, all the creativity that comes around. Like one of the most fascinating use cases is I talked to somebody in investment banking. They were saying, we want to take all of our deals before we go into the room. We're going to upload all of our slides or our deal documents, and we're going to say, act as a skeptic. Identify all of my assumptions and generate 10 really hard questions for me. And they're going to do it again and do it again and make sure that they have really battle tested and thought through that. Or you're getting ready to make an investment. Like, what are the underlying assumptions of this that might be wrong? And show me 10 ways they might go sideways. And starting to have expanding our horizons on the way we solve problems, what data could mean, looking at things from a broader lens. Now, how do you learn to do all this stuff, right? It's just text. And unfortunately, that's not true. It really matters, like you asked about the adjective, it really matters how you word things and what you ask for. And you still have to understand how do you represent the problem, express it, know how to ask for the solution, know in what series of steps, knowing the things that matter. And it also matters that you know, what's possible. If you don't know the building blocks and you don't know what's possible, you don't know to ask for it. And if you don't ask for it, it's probably not going to give it to you. So a lot of what we're studying is about how do we understand how to use these models effectively through language and represent problems and doing things. Now, before I talk to you about what we're doing, I want to give you some intuition about how these models work. So the way they train these models is they basically taught them to predict the next word in the sentence. So they would have showed it Mary had a little, and they would have tried to get it to predict lamb. Then they would have showed it Mary had a little lamb, and they tried to get it to predict its. And then they'd say Mary had a little lamb, its, and they tried to get it to predict fleece. And they did this over and over on huge chunks of the internet, books, all kinds of things. And over time, it learns how the patterns in the language on the left-hand side help predict what word comes next. So it really pays attention to language. And by the way, when you go into ChatGPT and it generates an answer and you see it going like a little bit at a time, that's because it's predicting a word at a time. It predicts a word, it adds it to the left side, predicts again, adds it to the left side, predicts again, adds it to the left side roughly. And so the left-hand side is basically the prompt, and the right-hand side is the output. So it's learning how patterns in our prompts, indicate what should come and what the next word should be. Now, how on earth this scales up to this complex reasoning we're seeing, I have no idea. Nobody really does. How you train it at a big enough scale and all this crazy stuff happens. So Doug and I have been doing a lot of research on understanding how the patterns in our language can be thought of kind of as building blocks. That if you teach somebody the pattern, you know the sort of emergent reasoning capability it taps into, and that becomes kind of like an innovation building block that somebody can take off and adapt the pattern to their domain in order to solve real problems. Now, patterns sound like this really complex thing, but we use them in our language all the time. So if you write a formal letter, you say, "Dear so-and-so, comma," and dear indicates respect. There's a purpose to that. You have the person's name to indicate who it's addressed to. You have the comma to separate the end of that from the rest of the content. So we use patterns all the time, and it's similar to that, but if you know these patterns, they become really powerful building blocks. So I'm going to show you one of the ones that we documented early on that's really fascinating, and it's called the persona pattern. And this is one that I just think is one of the most interesting. I always love to talk about it. And in the real world, if we have a problem we need solved, we don't have to know how to solve it ourselves. We just have to know who to go to talk to in order to get the solution. We could go talk to the IRS, or we could go talk to a nutritionist, or we could go talk to chief information officer, or whatever it is. And so you can replicate that in a large language model, and the way you do it is you just say, act as some persona, like act as a nutritionist, act as the IRS. And you can also say inanimate objects, like act as a computer that's been the victim of a cyber attack, and it can simulate a computer. And then basically what it'll do is it'll completely change its reasoning in the way that it does things based on the persona you give it. So I'm going to give you an example from my household. It's a persona I know nothing about, but I can fact check it. And it's act as a speech-language pathologist. So my wife is a speech-language pathologist for the school system. And she tests kids before they go into kindergarten, see if they need an IEP, basically specialized educational supports. So act as a speech-language pathologist. I'm going to tell you what a 3-year-old said, and you will write an assessment for me. The child said, "I need way woy." And so I tried to think about what my son sounded like at 3 and capture this in text. And ChatGPT says, based on the provided speech sample, it appears the child may be experiencing some phonological and articulation errors which are common in children around this age. The child's utterance appears to have errors in consonant production, possibly some difficulty with syllable structure. Specifically, the N and L sounds, the child said mead instead of need and woy instead of toy, assuming the intended words were need and toy. And it goes on and it says, you know, the child intended to, it's possible the child intended to say play when it said way, and it diagnoses it all, and it's all correct. And the difference is, as I said, ACT as a speech-language pathologist, and it tapped into all this reasoning. So that's a new computing building block that nobody knows how to use it effectively yet, and we're sort of discovering it. How do you use a persona to solve real-world problems and tap into emergent reasoning? Now, one of the other things that's really interesting is everybody's talking about AI, but we really should just be talking about generative AI, because generative AI is going to take over the world of AI predominantly. Everybody's talking about custom models, custom this and that, but basically what we're going to see over and over is we're going to narrow down to a very small number of models, more than likely, that can do all the work for us. And one of the examples of this that's really got me excited lately is GPT-4 Vision, which was just recently released. And from my perspective, it's by far the world's most advanced computer vision system. We think of, before it was like text, and then there's like all these custom computer vision modules and things out there. Well, now anybody with their phone with ChatGPT Plus can go and tap into the world's most powerful computer vision and instantly build out the most powerful applications. So I had Mexican like a week or two ago, and somebody at the table said to me, yeah, I'm not doing anything with ChatGPT, and he was a lawyer, and I'm like, let's talk. And so I snapped a picture of the table, and I was like, let's figure out who needs a refill. And I just said, here's the picture, who needs a refill? And ChatGPT comes back, and it's like, it looks like the glass with ice water is still fairly full, while the beer bottle seems to be nearly empty. So someone might need a refill on beer soon. Let me just go back. That would be incredibly difficult to do with any other computer vision technique. So if you wanted to do this right, you'd have to set up and have lots of images that were hand-labeled by people describing the current state of the table and who needs refills. So basically, you'd be drinking a lot of beer, drinking, set it down, eat some more Mexican food, take a picture of the table, label everything, do it again, and 10,000 times later, you'd be like dead from alcohol poisoning. You would have a model that could ask who needs a refill. And I created that model just by going and uploading the picture and saying who needs a refill. And then I thought, can it help me order, right? I want to eat something keto, and my waitress has just showed up. And so I snapped a picture of the menu, not a very good picture, and I just say, I need a quick keto option. And it reads the menu, and it says, go for the grilled chili relleno with smoked chicken and sliced avocado. It's a keto-friendly option that's low in carbs and high in fats and protein. Just make sure to skip any side dishes that may come with it. Now, the first time I looked at this, I was like, oh man, it did pretty well, but it messed up. The chili relleno has filled with corn, mushrooms, and other stuff. I can't eat corn. That's not really keto, but it's pretty good. It read the menu. And then I looked more closely at its answer, and I realized it said grilled chili relleno, and there's 2 of them on there, and the grilled chili relleno does not have corn, and nothing in there. And so it actually was better than the human in that case. And then I was going camping last weekend, and I bought a bunch of stuff, and I was like, I need to make sure I brought everything that I was responsible for. So I copied and pasted the text message that the person sent me into the bottom. I snapped a picture of everything I'd bought and put it out on the table, and I said, extract an inventory of what we bought. We were going camping, and we were asked to make breakfast burritos with this recipe. Did we miss anything in our shopping? And I just snapped a picture of what we had on the table, and it says, from your inventory, missing tortillas. That would be a problem. Eggs are missing, and hash browns are missing. And by the way, on bacon, it says present, assuming the meat in the plastic bag is bacon, because you can't exactly see it that well, but it looks pretty close. That's like the world's most powerful computer vision. You can imagine doing that in an aisle in a shopping store. Identify products, how much of what is sold, all kinds of things like that. And then since I'm going to keep you here too long already, I thought, well, I'll go ahead and order lunch. So I snapped a picture of this catering menu that was available. And I said, I need to order lunch for 15 people. This vendor, create a lunch order for me and draft the email. And so notice I just snap a picture of their menu, because I don't have this as data. And it turns it into a lunch order for 15 people, which I fact-checked it. It looks good to me. Half trays, it all seems reasonable. It's got a nice variety of stuff, and it drafted the email. I'll do a couple more, and then I'll wrap up here. I don't know, maybe you do brainstorming sometimes and you write a bunch of like random scrawl and you're like, all right, now we need to capture this and turn it into a plan. And somebody's stuck writing that thing down and capturing notes. Well, I dug out of my photos some examples of whiteboards that I thought were important enough to photograph, but I obviously didn't think they were important enough to write down what it was because I didn't have the information about what it was. And I say, everyone agrees that we should implement this new grading policy that we brainstormed on the board. Please extract the grading policy and draft an email that I can send to the attendees afterwards describing the policy. And here's the policy. And it's 100% accurate. I fact-checked my own policy. It took me longer to read the thing and actually dissect what it was because it was just kind of this, random thoughts. And it dissected everything that was on there. But the vision capabilities can also be in the real world, looking out like trucks, safety, risk, all kinds of things. So two things happening. One, we have these fundamentally new capabilities in computing like personas and that vision that are going to transform what we can do in terms of problem solving. And two, we have this completely new interface to computing, which isn't a GUI. It's not programming, but it's something that gives you basically the power of both and is more intuitive. And it's going to really transform what we can do. I'm going to talk 1 second about augmented intelligence, and then Doug's going to talk about this more. But we're starting to think about this not as some artificial intelligence replacement for people, because it does make mistakes, and it's not perfect, but as augmented intelligence that can help amplify and augment human creativity and problem solving to help people do things that they couldn't do before. And it's kind of like an exoskeleton for the mind that you put on that gives you all of these new capabilities. But replace people? No, that's not the way we're looking at it. We're looking at it as how do we use it to really radically improve what people can do. So, and I have to give a plug for my course, How Can You Learn Prompt Engineering? Well, if you'd like to take more, I have a course on Coursera that's free and some other courses. And then we're also in the process, and Doug will probably talk more about this, of creating different collaboratives around generative AI, also looking at training, looking at R&D, and also piloting projects and understanding how do we stand up teams, work together with industry to go and really transform what can be done. All right, thank you. And with that, I'm going to turn it over to Doug.
So one of the great things about listening to Jules is I always learn a lot of new stuff that I didn't know. And I also realize how much more I have to know to be effective at this. So it was fantastic and great talk. So I have a background in liberal arts. I was a sociology undergrad and master's student before I became a computer science PhD student. So it's always nice to start with a little bit of showing off what I learned from my philosophy classes. So Socrates is famous for saying the unexamined life is not worth living. It's unclear whether he said that before or after he said, I drank what? That's another story. But this is what I say. The unrecorded talk is not worth giving. And so both Jules and I have recorded our talks, and you can watch them later. And we'll also provide the material like the slides and so on. There's lots of clickable links here. So I'm going to talk about navigating our AI-augmented future. So hard to believe, exactly a year ago, almost a year ago, I think it came out at the end of November, ChatGPT escaped from the lab. And unless you've been frozen in carbonide for the last year, you're probably aware that ChatGPT is a generative AI large language model that synthesizes new and original content in a conversational manner. So that's typically how we use it. In fact, most people come to using ChatGPT much as an interactive Google search. You start by typing in these simple prompts like, generate me a poem about the French Revolution, and you get back a response. And unlike Google searches where you get back a bunch of links, which you then have to digest in some way manually, ChatGPT pre-digests a lot of stuff for you. But what happened almost instantly once ChatGPT escaped from the lab was people started predicting the end of the world. So if you Google, is AI the end of the world, you will find all kinds of articles about we're doomed, the AI apocalypse, AI will destroy humanity, and so on and so forth. And in the famous words of Ron Burgundy from Anchorman, boy, that escalated quickly. Now, is the world really coming to an end from generative AI? There's a lot more things that keep me awake at night worrying about the end of the world. There might be black holes coming our way. Nuclear war nightmare, probably a lot more likely to cause problems. Too much TikTok. There's quite a bit of evidence that TikTok is destroying people's minds, especially the minds of the young. Now, if generative AI really is the end of the world, then we don't have to spend a lot of time worrying about what's going to come next. However, I have a feeling that we need to stop worrying and love the bot. So anybody who remembers 1964, the famous Stanley Kubrick movie, Dr. Strangelove, How I Learned to Stop Worrying and Love the Bomb, well, it's 60 years later, now we're going to be loving the bot. So a couple things to start with. First of all, the barrier to using generative AI is ridiculously low. If you're willing to settle for the free version, you can just have a browser, and you can use OpenAI and Claude. It's a little bit limited, but it's not too bad. If you're willing to spend about as much as 3 expensive cups of coffee at Starbucks a month, I looked up using ChatGPT and found that pumpkin spice latte is the most expensive cups of coffee. It's like $7 or so. So if you're willing to spend that much amount, you can get the paid version, and it's awesome. And it's getting better. But of course, as Jules pointed out before, we have to make sure we set our expectations accordingly. Lots of my colleagues, famous computer scientists, Peter Denning, we'll see Bertrand Meyer later, have come on record saying all kinds of interesting things about ChatGPT. And they're usually along the lines of the following. When you use ChatGPT to analyze documents, you discover most of what it tells you, it seems like you've already heard somewhere, no radical departures from what others have said, frequent excursion into nonsense, speaks with great authority even when it's spouting nonsense. That was me my first semester in grad school. When I became a computer science grad student, I didn't make a lot of sense. I probably said a lot of things my advisor thought they'd heard many times before. But the thing to remember was nobody expected me in my first semester of grad school to write science and nature articles and get them published, or write competitive NSF or NIH grants. What we did is we worked together and we got smarter. I got smarter. Hopefully I got smarter. And so I don't spout as much nonsense quite as much. So we need to make sure we think about this in the right way. And again, riffing off of what Jules said before, if we think about this from the generative AI point of view, and the AI means augmented intelligence rather than artificial intelligence, you see the goal is to supplant, not supplant us, but supplement us, make us better. And again, as Jules said, it's like an exoskeleton for your brain. If you're familiar with Professor X from the X-Men, he wears Cerebro, and he gets to be much smarter. So that's the right way to look at this. It makes us more effective when we work together with it. Just like I got better because my advisor worked with me and guided me to get past the early stages of being confused and spouting nonsense. What I'd like to do now is talk about some of the impacts that AI-augmented tooling is having on the way that we build and use systems. And I'll talk a little bit about things that are software-related, but software runs the world, it eats the world, and a lot of the stuff I'm going to talk about is also relevant for many other domains. So I'm going to start out with a high percentage prediction. Anybody here remember Dr. J? Those of you who are our age. So he was a famous basketball player for the Philadelphia 76ers, and he was famous for dunks. And they said, Dr. J, why do you like dunks? He said, it's a high percentage shot. So let's start out with a very high percentage prediction. Generative AI is having a very transformational impact on the practice of software and system development. And Jules gave you some examples. I'm going to focus a little bit more on building systems and tools. I do this every day. Why I am 10 or 100 times more productive than I was a year ago is because I'm using tools like Amazon Code Whisperer or GitHub Copilot to help me do my programming. I program a lot for my classes. I program a lot for my research. And it takes away the cognitive load. I don't have to be concerned with mundane, tedious details. I let my little buddy, my pair programmer, help me out. And I've been applying a bunch of this to my courses at Vanderbilt. I'll talk more about that in a second. I've got a whole series of YouTube videos that talk about what we do in our courses. Not everybody's as equally bullish about this, however. There's also other famous people in our field, especially software, who say things like, AI does not help programmers. Here's a tip for you. If you want to make sure you don't go down in history as saying ridiculous things, don't make statements like this. There's another famous statement by Thomas Watson, CEO of IBM, who said in 1943, there's only a market for 5 computers in the world. Boy, did he miscalculate that one. Another famous quote by one of the richest men on earth, Bill Gates, probably in 1982, who needs more than 640K memory? So don't say things like AI does not help programmers. What happens here is people will use the tools in the wrong way. They will use the wrong tools. They won't do prompt engineering properly. And they try it once or twice, and it doesn't work. And this is very similar to an analogy that Jules loves to use, so I stole it from him and threw in some other photos. Imagine you were Michelangelo or a sculptor, and you picked up your chisel, and you hit a block of marble once or twice, and it didn't instantly turn into the Pieta. And you said, see, I'm no good as a sculptor. My chisel is broken. Sculpting is a bad profession. That would be silly. You would mock that person for giving up so early. And I've actually decided that people who do 1 or 2 ad hoc approaches, throw up their hands in despair, and give up are actually practicing degenerative AI, not generative AI. And I asked ChatGPT to generate me a visualization of degenerative AI, and this is what it came up with, or really Dolly. So here's the tree of AI augmented knowledge, and here are the people who are shackled to their old way of thinking about things. And I thought, that's pretty darn good. So don't be degenerative is my take-home message. So let's talk about some of the opportunities in this space that may apply to things that we're all collectively doing these days. So one thing to do is think about how we do the system or software development lifecycle. Many of you, I'm sure, work in project management, or you manage people who do project management. And let's talk about some of the things you have to do. One of the things you very quickly realize is there's an enormous amount of data that's produced in the life cycle of systems that is not well leveraged today. Just as a very simple example, some of my colleagues at the Software Engineering Institute at CMU, where I was the CTO for a number of years, they're doing some interesting work where they're reading Jira repositories of tickets reporting problems with software, and then trying to predict areas using AI that will be heavily laden with technical debt, which is a big deal because you want to pay down that technical debt, or you end up with huge costs down the life cycle. So that's one nice example. More broadly, there's all kinds of documents that are created throughout the life cycle of projects. You've got requirements documents, you've got software and system architecture diagrams, you've got test plans, you've got infrastructure as code, deployment scripts, you've got all kinds of things that you maintain in terms of user stories and so on. And people are notoriously bad at understanding those things at scale. Many of these artifacts can and are and will continue to be in the future analyzed much more effectively at scale, better, faster, cheaper than by using humans alone. And in fact, I think this is the really low-hanging fruit of using generative AI in real life. And let me tell you why. A lot of the focus, at least in the academic computer science discipline, has been on using generative AI to create code or create tests, which is pretty cool. We do research on that. We're making good progress. The problem is that the baseline of utility there is perfection. If you had a compiler that generated 90% right solutions, but they were really fast, you probably wouldn't use that compiler because it would put you at risk. When people look at code, the skeptics, my colleagues who are skeptics, they say, see, it's not perfect, therefore it's no good. And I don't agree with that, but they may have a point. However, there's lots of parts of the life cycle, especially the earlier phases, where utility is more important than perfection because there is no baseline. If you take a look at people who review large documents, it takes people an enormous amount of time, and they're still wrong most of the time because people can't keep hundreds and hundreds of pages of documents consistent in their heads. So as an example of this, I'm doing some work with my colleagues at the Software Engineering Institute where we're working on nuclear weapons programs, where you really want to make sure things don't go boom at the wrong time. So they have very detailed specifications, like the Air Force Manual 91-119 specification, or the AFMAN spec, that has all kinds of requirements and policies and guidance for how to write nuclear-safe systems. Many smart people have looked at this document for a very long time. You can see this version is 2012, so it's been a decade or more. We use ChatGPT very quickly, because it's a public document, to analyze this document to see whether there were discrepancies or inconsistencies in the guidance it was providing. And lo and behold, there was all kinds of discrepancies, despite the fact that really smart people have looked at it for a long time, and it's very important to be correct. So this overall area, this theme of discrepancy analysis, is extremely important in lots of domains. Law, accounting, auditing, software safety, almost anything where you take documents and you compare them with other things. So keep that in mind. We'll talk more about that. Another thing to note is that the new generation of these tools, as of like yesterday, are getting a lot better at being able to give you correct responses as opposed to hallucinating. So one of the classic problems, Jules pointed this out with the so-called autoregressive way of training the large language models, is it'll always give you an answer, even if the answer makes no sense whatsoever, because it's just basically looking for probabilities, statistical probabilities of chaining words together. That doesn't work in a lot of domains. What we're doing now, however, is using something called retrieval augmented generation, or RAG. And if you look at these links, you'll learn about that. And this has just been baked into the new version of ChatGPT as of yesterday. What it does is it takes the documents and it analyzes them and it encodes them using something called vector space encoding. And therefore, when you combine that with a chat model to be interactive, it's much, much more likely to give you correct responses. And if it can't give you a correct response, it will say, I don't know, which is actually a much better response than just making something up and hallucinating. So this is going to transform stuff, and we worked with some folks from IBM where they're taking all of their documentation for their many, many software products, they're encoding it with RAG, and then they're building essentially chatbot interfaces for people to learn how their systems work. Think about all the other products that we do out there for supporting people doing call centers or anything where you've got to be able to give answers that you'd like to be correct. This technology is massively transformational, and it should really drive down the problems of hallucinations and wrong responses. I won't say to zero, but much closer. And in fact, close enough that IBM is actually guaranteeing to their customers now who use their tools, there will be no copyright violations in the answers, there will be no patent infringements in the answers, and, get ready for this, no hallucinations in the answers. That's a pretty bold statement. Not sure I necessarily understand that that's going to happen every time, but they're getting confident enough that they're going to guarantee that and indemnify that. So let's go on and talk a little bit more about this. Another thing that's really fascinating, especially in these very safety-critical domains, is not just looking for consistencies within a document, but looking for inconsistencies between the policies in the guidance document and then the actual embodiments of code for those systems. So again, if you want to build nuclear weapons systems that are safe, there's all kinds of coding standards you have to apply, and you would like to be able to extract from them, much like Jules had shown, the rules, and then be able to go check the code to see if they conform to the rules. This is something that's known as static analysis. We'll talk more about that in a second. But basically what we're doing, again with my colleagues at the SEI, is extracting the rules from these documents and then checking the code to see if we can identify automatically for violations in the rules. Very, very powerful stuff. This is yet another form of discrepancy analysis that involves a broad range of stakeholders. And the reason why it involves a broad range of stakeholders is unlike classic tools for static analysis, which are written in esoteric formal languages that only a few people can even understand. This is written in English, and therefore a much broader range of stakeholders, like systems engineers, various people who are subject matter experts, program officers, and so on, can be participants in understanding what's being analyzed and reviewed. Next thing I want to talk about quickly is formalizing the discipline of prompt engineering. Jules touched upon this. This is basically just structuring the interactions with these large language models, programming them, in a sense, to solve complex problems using natural language. The key point here, and Jules did a great job in his talk of making this clear, but I'm going to underscore it even more. The focus is moving from programming in the classic sense with Python or JavaScript or whatnot to problem solving, which is incredibly transformative, especially for non-computer scientists. Now, it's still useful for us. I've got a nice video here where I show how I took some code I wrote and with ChatGPT, I refactored the code automatically to extract common reusable elements and then make it so it was a lot cleaner and easier to maintain. That's pretty cool. But what's even more cool is all these other non-CS domains that want to use computation, but the people don't want to become programmers. Classically, when people came to Jules and I and Dana and said, we're physicists, we're chemists, we're biologists, we're classical civilization professors, we want to use computation in our work, we would say, great, let's teach you Python, let's teach you Java, let's teach you JavaScript. Totally the wrong thing to do, because most people don't want to program in those languages, and they're not going to be very good at it. With prompt engineering, you can get non-computer scientists to use computation effectively. And one of the key ways to do this is through prompt patterns, which is inspired by work on software patterns, which we've worked on for decades now, which are basically ways of taking solutions to common problems that arise in a particular context and document them so that humans who are programmers can apply those patterns and be more effective when they write the code. Cool idea. Prompt patterns are the same thing, just looking at how we interact and program LLMs. You can focus on more than just the coding phases. You can focus on the upstream activities as well. And one of the things that's really cool about prompt patterns for LLMs is, unlike software patterns, it required people to understand them, which was hard, and then know when to apply them through going around and looking at their software development processes and seeing where to apply them. We can now automate that stuff in ways we had a hard time doing before. People have been pushing back on prompt engineering since about 8 months ago when all these $300,000 a year jobs came out. People said, oh, gee, prompt engineering is just a flash in the pan. Very shortly, the computers will be so smart that you'll just have to think about the problem and the solution will pop out fully formed and correct. That's completely wrong, by the way. Jules gave you some good examples of that. especially when you get into more precise things, you have to be much more systematic. However, even if you subscribe to the fact that computers are going to get pretty smart, as we start using this stuff for real in systems where the right answer delivered too late becomes the wrong answer, in other words, mission critical or safety critical systems, we've got to think about all the other engineering issues, maintenance, testing, configuration management, version to version release control, updates. This is what's going to be important for the future of this stuff in practice. Otherwise, we're going to create a huge bow wave of technical debt. All right, so the last thing I'm going to talk about here is how I'm actually applying this in my work at Vanderbilt. So I teach a bunch of courses here at Vanderbilt, and these are fun courses on mobile device programming and cloud programming and so on. You can learn about this stuff. We're building both AI and non-AI components using all the tools that we're about to talk about. These are what are known as mezzanine courses for upper division students and graduates. That's important because it avoids a lot of the thorny issues of trying to use generative AI for the intro courses. And that the jury is still out if this is a good thing or not. Dana teaches a lot of these courses. We're concerned that if the students don't take the time to master the basics and just start using this exoskeleton for their brain, they're not going to be in a good position to solve the harder problems, or more importantly, to know when the generative AI is producing gobbledygook. So big issue. Haven't quite figured that one out, but let's go ahead. When I teach, there's a lot of things I think are really fun. I love to give lectures. I love to create code examples. I love to review my student code. And there's a lot of things I don't like to do. I hate to create tests, quizzes, knowledge check questions. I don't like to grade the final assignments. I don't have to summarize the contents of my videos. Those are boring. So my goal is to figure out how to use this stuff to make my life more interesting, but do the stuff I have to do much better. So I'm going to focus on one little piece here, and this will show you sort of a case study of how I think about this stuff. And even though you're probably not doing the kind of thing I'm doing with my teaching, it may trigger some thoughts as to how you can problem solve in a similar way. So one of the things that's a real concern for us as educators, especially in computer science, is it's so easy to generate solutions to problems with generative AI from the specification alone. And I don't have time to go into this in detail, but I'll just give you the quick Cliff Notes version. So we have a data structures class. It's the second class that people take as undergrads here. We have a teacher who's a wonderful teacher. He's taught this course for decades, and he hadn't used ChatGPT. So I sat down with him at a retreat recently. I said, hey, Jerry, you never heard of ChatGPT? You never used it, right? He's like, no, never used it. I don't think it would really be relevant for my class because my assignments are pretty hard. I said, how about that? So I said, send me your specification. He sent me a 7-page PDF specification, much like what Jules was showing. And I said, OK, watch this. I said, please read the given PDF file and generate a C++ program that implements this specification. And in about 5 minutes, it read the file. It parsed everything out. It understood the problem. And then it just started generating the code, basically class by class by class. And we were watching it because ChatGPT kind of scrolls a little slowly, right? It's like it's sitting there typing. It's like texting back to you. And after 5 to 10 minutes, Jerry's face turns whiter and whiter as he's looking at the code. And I said, isn't that great? What do you think? What do you think? Isn't that cool? He's like, I think it's time for me to retire. And I said, whoa, that's not the answer I was looking for. But then I thought to myself, this is like the day before class started in this semester. And I thought, I am teaching a course that is so advanced that there's no possible way that ChatGPT could generate the solution to my course, right, my assignments. But I thought, well, maybe I should just check to see what happens. So I gave it the specification. Just keep in mind, this is like the day before my first class when my assignment's coming out. And lo and behold, it quickly generated a solution to my assignment that was basically perfect. Now I've got a problem, right? When it was Jerry's class, no problem. But now it's my problem. So what do I do? Well, here's the interesting thing. And this is a really important take-home point. When you run into problems caused by generative AI, the best thing to do is ask it for help. So I said, how can I modify my assignment specifications so they're harder to reverse engineer? ChatGPT. And it said, oh, well, thank you for asking. And so it gave me a bunch of really good responses, most of which boiled down to generalize your specifications so it's harder to reverse engineer through a tool. I'm like, that's pretty cool. However, now there's a whole new set of problems, right? Now I don't have a detailed spec, so students can be much more creative in how they solve their programming assignment. Now I've got a ton of things I've got to think about from a grading point of view. Wow. Up to this point, because my specs were pretty well detailed, we could write very specific unit tests and mocking and white box testing that would automatically review the students' submissions against the tests. Pretty cool. Doesn't work anymore because the spec is too loose now. And there's other problems as well. So one way we solve this in some of our intro courses is we have an army of graders, usually undergrads these days because they're smart. They come to Vanderbilt, and we can tap into them. But then we have a new problem. We've got 30 graders. You have the inter-rater reliability problem. If you remember the Olympic sports, the Soviet judge would judge a person with a 1, and the US judge would judge them with a 10, right? We got a problem. So how do we solve this issue? Well, when life gives you lemons, you make lemonade, and of course you make lemonade generatively. And so what I'm doing is using augmented intelligence to improve how I do the grading in my course, and this is what I do. So I have a very special way of teaching my class and grading things. Students turn their assignments in, and I review them all by hand at first, give them detailed comments on what's wrong, and then I extract those comments out into a frequently made mistakes file and a video I'll talk about. Then they take the comments, they go fix them, and then they submit them, and my TA grades them. So if they do their work, they should all get perfect scores. They don't always get perfect scores, but that's a whole other issue. There's some things that generative AI just can't fix. So keep in mind, what I'm about to show you is how we use automation here. So for the instructor review phase, I review the code and I write down comments about what they're doing wrong. Historically, I couldn't do much besides put out a video that says, hey folks, go look at this video and you'll fix your code if you follow it, my descriptions and instructions on how to improve things. What I do now in the brave new world of ChatGPT is I take that file, and with the help of one of my TAs, we run it through ChatGPT and we extract out a JSON file that says what the problems are, and it automatically generates most of this, that says what the problems are and then how to fix them based on the file I create here. So we're reverse engineering a rubric that people can then use to evaluate whether it works or not. What's so cool about this is I no longer have to rely on my army of TAs and graders to read my mind and make sure that they understand how to do the evaluation. Instead, what we do is we take that JSON file and then we create a tool using ChatGPT to act as a static analysis grader. And so it can read those instructions and then go look at all the student solutions one at a time and find the things that they either shouldn't have had in the code but did, or didn't have in the code, but in other words, either stuff that they should have had and forgot to add, or they added the wrong thing. So we're now able to automatically grade stuff. And this way, we can greatly scale up the process. We can make it much more predictable. And whenever it does do things wrong, it occasionally gets things wrong, either the TA can go and check whenever an error is reported, so they can find it, or the most scalable and precise way is you give it back to the students, it's not graded correctly, and there will instantly be people at your office hours the next time saying, you didn't grade my program correctly. So this means that the consequences of getting things wrong are low. Now, what's interesting about this, and this goes back to another theme, when you can't get your GPT to do the right thing, you simply work with it to make it work. So sometimes it doesn't always detect the problems. And so what I do is, rather than give up, I engage in Socratic dialogue with ChatGPT, and I say, you got this analysis incorrectly. Tell me how I can improve what I asked you to do so the next time you get it right the first time. And lo and behold, it tells me. It says, what it usually says is, give more context. Context is your friend with LLMs. Context is king. Good luck doing this with any other tool you've ever worked with up to this point. If you have static analysis tools or you use an interactive development environment and things aren't working, imagine going to your compiler when you get a compiler and say, please tell me why my compiler occurred in my code. And of course, the compiler will be like, huh? Like, why are you telling me this? I'm a compiler, not a language model. So this is very, very powerful, and it's a good theme to think about how to work with the tools to do things better. All right, so to wrap up, a couple years ago, we wrote a report that talked about the future of software engineering. One of our conclusions was that humans and AI should work together as trustworthy collaborators. We thought that was a 10 to 15-year vision. It became true almost instantaneously. However, the trustworthy part is still at issue. If you think about this as generative augmented intelligence, then we're in pretty good shape because people are in the loop. If you think about it as generative artificial intelligence where people are out of the loop, it's not really ready for prime time yet, and that may take a while. However, if you look at this New York Times article, you see how IBM is getting all excited with their use of retrieval augmented generation to make things much more precise. The key themes to remember: moving away from programming in the traditional way to problem solving with computation. that is going to unleash things. It's especially important for non-CS people in all these other fields that you guys are part of that are using computation to make your solutions better. Everybody will soon be a programmer. Not a traditional programmer, but someone using large language models to solve their problems. And this is just something too much fun. So I love to show visualizations when I teach. I love to get that right brain part clicking. So I was teaching a course on multi-threaded programming, and I wanted to get my students to understand the difference between multi-threading in theory and multi-threading in practice. So I asked ChatGPT and Dolly, I said, please generate me an image that shows a bunch of dogs eating from their own bowls in a very orderly way, and then generate me a picture that shows a bunch of dogs eating from each other's bowls in a chaotic Scrum-like way. And that's what it produced. And I thought, first of all, that's pretty darn cool, right? But then I took that image and I fed it back into ChatGPT and I said, why is this funny? And it answered. It actually was able to look at the pictures and it explained the theory and the practice, and it said basically that the humor comes from the stark contrast between the two scenes. And basically it said that sometimes there's an age-old observation that in theory and practice are the same, but in practice they're not. And I think we can all understand and appreciate that. So I thought that was pretty darn cool. I did some other neat things with other examples of images, which I will skip. But to Jules's point, amazingly powerful and transformational stuff. We have an opportunity now to focus on what's fun in whatever we do, what's creative, not get wrapped up with all the mundane details. There's actually a pretty funny experiment. This is something called the obfuscated C code contest. And someone has run that through ChatGPT to show how it does a very good job of understanding obfuscated code. So for all those people who work in projects where people think they get job security from writing code that nobody can understand, now we can use ChatGPT to make sense of it, which is a good thing. So lots of stuff remains to be done to make this great. This is the time to jump in. I asked ChatGPT, what are the most important technological innovations over the past 1,000 years? And this is what it generated. And I think it's a pretty good list. Printing press, steam engine, electricity, computers, and the internet. And of course, this is where we are now. I think this is just as transformational. Maybe it was a little biased in giving me that answer, but I think it's pretty good. We're at a point where we can make a difference. Let's go out and enjoy it while we're doing it. But be aware that just like there's a digital divide where you have the people who understand or have access to computing and the internet and those who don't, and it causes economic disparity, we're about to enter the digital chasm where we have people who know how to use AI and those who don't. To Jules's point, 10, 100, 1,000 times more productive. That is a little scary. We have to be careful about how we're going to deal with that. There's opportunities for social inequity and so on. However, my last slide here, the advent of generative AI provides a very unique, once-in-a-lifetime opportunity to level the playing field. Why is that? If you're like me and you have a sociology undergrad degree and or you have a kid who has a sociology undergrad degree who wants to go out and become more economically viable, they can go to a boot camp. We have boot camps at Vanderbilt. And in 24 weeks, you'll come out able to build websites. However, you'll be competing with people with decades of experience at building websites. So you may not be able to be competitive. For generative AI, there's really nobody on the planet who has more than 6 to 12 months of experience as a prompt engineer. So you don't need a computer science degree. You just need to be able to think clearly, express yourself articulately, and have a passion for playing around with this stuff. And you can be as good as anybody right away. So that is quite a transformational thing. So with that, I will wrap up, and let's have a discussion.